adding or subtracting fractions with trig functions. Let's review the algebra first. You can only add or subtract fractions if they have a common denominator. So I'm looking at this first example. Obviously, I do not have a common denominator. What do I need to do? I need to change the fractions so they have one. Here's the steps. First, factor each existing denominator. X doesn't factor, it's its own factor. Y doesn't factor, it's its own factor. Well, that means the LCD, the lowest common denominator, is just going to be the product of X and Y, X times Y. This one here is missing the Y. I can multiply it on as long as I also do it to the top. This one here is missing the X. Again, I can fix that as long as I do the same thing to the top. I now have 3y over xy plus 4x over xy. These fractions do reduce. Don't reduce them. If you do, you'll just get back to where we started. We have purposely unreduced these fractions so that we can now add them together. It's very easy. The denominator stays the same and we add up the top. These are not like terms, so I have no way to actually combine them. I can just write it down. The last thing to check is whether I can factor any of the pieces. If I can, I might be able to do some canceling, but the top doesn't factor. I'm finished. This is the final answer. Let's try it now on the trig example. Again, I'm trying to subtract here. I need a common denominator. This doesn't factor. This doesn't factor, which means the common denominator is just going to be the product. This one is missing a cosine x, so I'll fix that top to bottom. This one is missing a sine x, so I'll fix that again, top and bottom. My fractions are now sine x cosecant x over sine x cosine x minus cosine squared x, that's cosine x times cosine x, over sine x cosine x. Now I can actually subtract. I subtract the tops and the bottom stays the same. Again, at first glance, it may appear that there's nothing I can do here, but look carefully. Sine x cosecant x, those are reciprocal functions of each other, so I'm figuring this is going to simplify. Cosecant x is just 1 over sine x. In other words, for that little piece there, I can reciprocate that to the bottom. I'm talking about the bottom of that term. Sine x cosecant x is the same as sine x over sine x. The rest of it stays the same, but of course sine x over sine x is just 1. And now look what I have. On the top of this thing, I have 1 minus cosine squared x. That's directly from the Pythagorean identity. 1 minus cosine squared x is just equal to sine squared x. And there's still more. Everybody's now just being multiplied or divided, so I can look for common factors, and I have a sine x on the bottom to get rid of a sine x on the top. I'm now down to sine x over cosine x, and according to the quotient identity, that's just equal to tangent x. So after all that simplifying, our final answer turned out to just be tangent x. Let's look at one more type here. It's really the same principles. I want to subtract these two fractions algebraically. I try to factor, but I can't. I try to factor here, but I can't. That means the LCD is just the product of the two pieces. This one is missing an x minus 1. Be careful here. I got to multiply top and bottom by x minus 1, and here top and bottom by x minus 2. So let's write down what we have. This new fraction is now x minus 2 on the top, multiplying by 1 doesn't really do anything. The bottom, I made it what I wanted it to be, x minus 2, x minus 1, minus, let's see, 3 times x minus 1. I'm going to go ahead and multiply that because the tops get combined. So that's going to be 3x minus 3 up there. And then the bottom, I already know that. Now it's time to subtract. Be careful here. When you subtract, you need to subtract this entire top. In fact, you might even want to write it down, minus parentheses 3x minus 3. The whole thing needs to be subtracted. The bottom, of course, stays the same. In order to subtract that whole thing, I'm going to have to distribute that minus throughout. So it becomes minus 3x and then plus 3. When I combine like terms, let's see, x take away 3x is negative 2x. Negative 2 plus 3 is positive 1. My denominator stays the same. Am I finished? Well, negative 2x plus 1 does not factor, which means I can't go any further. Here is the final answer. Okay, let's see how this plays out with the trig example. I can't factor that denominator, I can't factor that denominator, so the LCD is simply the two pieces multiplied by each other. I'll fix this one top to bottom. The other one needs a sine theta minus 1 top and bottom. And so each fraction is different now. The first one, sine theta minus 1 on the top, and then that LCD. And the other one has sine theta plus 1 on the top, and the LCD. Okay, and then I can subtract. Why don't we save ourselves a step here? I know that I need to subtract this entire top, which means I'm going to be distributing this to both pieces. I'm going to end up with sine theta minus sine theta. Well, those two pieces are going to go away. And then I'm going to have negative 1 minus 1 after I distribute, meaning the new top is just negative 2. The sine theta is dropped out, and negative 1 take away 1 is negative 2. On the bottom, I would often leave that factored out as it is now, but watch what happens if I multiply it together. It's a FOIL problem, but it's one of those nice FOIL problems. That's why I think I should try it. Sine theta times sine theta is sine squared theta. The middle terms cancel out because you get a plus sine theta and a minus sine theta. And then the last is minus 1. And then when I'm looking at this, I think, wait a minute, sine squared theta minus 1, that's a part of the Pythagorean identity. That's the one where if I move the 1 over here and then the cosine squared to the other side, I'll have sine squared x minus 1 equals negative cosine squared x. So that means, going back to our problem, that we have negative 2 over negative cosine squared theta. Well, the negatives drop out, leaving me with 2 over cosine squared theta. That's pretty simple. It does involve only cosine or sine, so some people might like that, but I suppose technically I could have fewer symbols if I reciprocated the cosine squared up to the top and called it secant squared theta. And so we'll call this for now our simplified answer, 2 secant squared theta. Thanks for watching.